Welcome to a lesson on the law of sines. The goals of this video are to derive the law of sines and also to solve triangles using the law of sines. But first, a triangle that is not a right triangle is called an oblique triangle, as we see here. Until now, we've only been able to solve right triangles. However, the law of sines will allow us to solve oblique triangles as well as solve new application problems. So here are the requirements for solving oblique triangles using the law of sines. We must be given angle, angle, side, or angle, side, angle, meaning one side and two angles are known, or side, side, angle, where two sides and one angle not included between the two sides are known. Now, side, side, angle tends to be a little more involved because it can lead to more than one possible triangle, so this case will be covered in a different video. And we should mention that oblique triangles with side angle side and side 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 can also be solved using something called the law of cosines, which is covered in a different video as well. So let's go ahead and state the law of sines. For any triangle ABC, the ratio of the sine of an angle to the opposite side that angle is constant, and it can be expressed in two different ways. We either have the length of the sides in the numerator and the sines of the angles in the denominator, or we can state it using the reciprocals. And I like to use this form. The sine of angle A divided by the length of side A must equal the sine of angle B divided by the length of side B, which must equal the sine of angle C divided by the length of side C. So what this is saying is that these ratios will be constant in any triangle. And what's going to happen is we're going to use two of these ratios to set up a proportion where one of these values will be unknown, and then we can use the fact that cross products are equal in a proportion and solve for the unknown value. But before we do that, let's take a look at an animation. Up here in this table, we have the ratios of the sines of the angles divided by the length of the opposite sides. And what we'll notice is when we change the triangle by changing any angle or the length of any side, notice that these ratios remain constant. This is illustrating the property of the law of sines. So regardless of the triangle, if we take the sine of the angle and divide by the length of the opposite side, that ratio remains constant. Let's go ahead and see if we can actually derive the law of sines. If we have any triangle ABC and construct an altitude from, let's say, vertex C to the opposite side, notice what happens is we form two right triangles, a smaller right triangle and a larger right triangle. So we could say the sine of angle A is equal to h over b in this small right triangle, and we could also state that the sine of angle B is equal to h over a in the larger right triangle. So if we have these two equations and we solve them for h, we would have h equals b sine A and h equals a sine B. Since they're both equal to h, we could state that b sine A is equal to a sine B. And now if we divide both sides of this equation by AB, notice on the left the b's simplify out, and notice on the right the a's simplify out. So we're left with sine of angle A divided by the length of side A must equal the sine of angle B divided by the length of B. To get the third ratio stated in the law of sines, we could construct an altitude from vertex A and show this is also equal to sine of angle C divided by the length of side C. Okay, let's go ahead and take a look at a problem. We want to solve the triangle where angle A is 48 degrees, angle B is 54 degrees, and side A has length 12.5 feet. Now it's not important that our triangle is to scale, but what is important is that if we call this angle A, this must be side A. If we call this angle B, the opposite side must be side B, and if this is angle C, this must be side C. Let's go ahead and record the given information. Angle A is 48 degrees, angle B is 54 degrees, and side A is 12.5 feet. Okay, before we get too excited and try to use the law of sines, we should take another look at this triangle. We know the sum of the interior angles must equal 180 degrees. So we can go ahead and find the measure of angle C, since we know that C plus 48 degrees plus 54 degrees must equal 180 degrees. So the measure of angle C is equal to 78 degrees. So now what we're left to find are the lengths of side B and side C. This will require the law of sines. Again, what we're going to do is pick two of these ratios where three of the values are known, and then we'll solve for the remaining unknown value. So we do have to have the measure of one angle and its opposite side to start with, and so we'll use angle A and side A to get us started. So the sine of 48 degrees is to 12.5 feet. Now to complete our proportion, let's go ahead and use angle B. So we'll have the sine of 54 degrees to side B. So again, notice we have one unknown value. So now we can cross multiply. So we have B times sine 48 must equal 12.5 times sine 54. So now we can solve for B by dividing both sides by sine 48 degrees. So now we'll have B is approximately equal to this quotient. Let's go ahead and get our calculators out. Make sure that we are in degree mode. And our numerator will be 12.5 times sine 54 degrees divided by sine 48 degrees. And so it looks like it's about 13.6 feet for side B. Now we still have to find the length of side C. We cannot use the Pythagorean theorem because it's not a right triangle, but we can use the law of sines again. To get us started, I will use the ratio of the sine of angle A divided by the length of side A. And now we'll use angle C, so the sine of 78 degrees divided by the length of side C. So again, this proportion is stating that the sine of 48 degrees is to 12.5 as the sine of 78 degrees is to the length of side C. We'll go ahead and cross multiply again. So we have C sine 48 degrees must equal 12.5 times the sine of 78 degrees. To solve for the length of C, we'll divide by sine 48 degrees. Now we'll go back to the calculator and find the value of this quotient. 12.5 sine 78 degrees divided by sine 48 degrees. And C is approximately 16.5 feet. Now one last check to make sure we didn't make a calculation error or misplace a decimal. The longest side should be opposite the largest angle. So here's our largest angle of 78 degrees. 16.5 feet is the longest side. And the shortest side of 12.5 should be opposite the smallest angle, which it is. So this is a nice way to double check our work one last time to make sure we didn't make a mistake on the calculator to solve our right triangle. Okay, so there are a couple more videos on the law of sines. One more that deals with the ambiguous case, and at least one other that will deal with solving application problems. I hope you found this introductory video helpful. Thank you and have a good day.